Hello students, now here we will start our chapter 4. Chapter 4, that is moments, skewness and kurtosis. Now already we have seen measures of central tendency, the dispersion of frequency distribution in previous chapters that help us in their summarization and comparison with each other. The measures of central tendency tells us the representative value of the data as mean, median, mode. These are representative values, while the measures of dispersion gives us the idea about the variation in observations about mean. That is, it is a definite value or a typical value. But both of these things fails to reveal whether the scatter of the values on either side of the mean is symmetrical or not. Symmetrical means what? On both sides it is what? Same. And not symmetrical means what? On one side it will be more and in another side it is less. Or in the right side it will be more, in left side it will be less. Such a things are there. Or if it is symmetrical, then we get a bell shaped curve there. Okay, if we plot a graph of them, so we get a bell shaped curve. So these measures also do not describe a frequency distribution in the sense that could not be two or more frequency distribution with same averages and dispersion but still different from each other. Means what? Here, and these measures of central tendencies, sometimes what the observations are different, the examples are different, still we get the same average, I mean same mean. So here we are unable to say about the symmetry of them. Okay, so also the dispersion doesn't give the same thing. Fine. Now it gives us the same shape and same pattern in the distribution. So thus there is a need to develop some more aspects for describing these characteristics of frequency distribution. Which characteristics? The characteristics of what? Symmetry, or they are symmetric or not symmetric. What are they? Okay. So these aspects, these new aspects are what? These one. The skewness, moments and what? The kurtosis. Skewness, moments and kurtosis. Now what is skewness? The skewness means what? The lack of symmetry. Skewness is basically the lack of symmetry, or you can say the opposite of symmetry. This refers the shape is symmetrical or not. The skewness tells us the shape is symmetrical or not. It also gives the information about the nature of distribution of items in a series. Means, as I say earlier, that it is towards right more or towards left more. That thing also gives by whom? The skewness. Now these moments, what are these moments? The moments are used to describe the various characteristics of frequency distribution. Now we will see them further. Okay, and kurtosis gives us the flatness or the peakness of the frequency curve. Sometime it will be flat, sometime it will be peaked. Fine, that is gives by what? The kurtosis. So we will see one by one. Now basically, first of all we will see the skewness. So towards skewness, let us see what is symmetry. It gives us the information about this lack of symmetry. So first of all, let us see what is meant by symmetry or the idea of symmetric distribution. What does it? So let me say idea of symmetric distribution. Symmetric distribution. So what does it basically? So a frequency distribution is symmetric about A. If. What are the conditions? The first condition is that the spread of the frequencies are same on both sides, or is the same on both sides. As I say earlier that we get a bell shaped. You have already seen the bells in our temples. So bells are equivalent on both sides. So that's why the shape is known as a bell shaped curve. So here the frequencies are spread in a same way or in a same series in both sides of the central point or of the center point of the distribution. Now how does it? For that, let us see an example. Suppose now I have a data as x and the corresponding frequencies. Now x is 11, 13, 15, 17, 19, 21 and 23, and the corresponding frequencies are 3, 4, 6, 9, 6, 4, 3. Now look at here. Here the frequencies are 3, 4 and 6. Here it is in decreasing order. Look at it, 6, 4 and 3. So in both sides this is what? Symmetric. Means the frequencies are what? Symmetrical about this mean what? 17 here. These are same on both sides. Fine. The same thing is given here. Now the next thing is that if the frequency curve is folded, we are doing a fold there, is folded about the ordinate, as we say the point A. So about the ordinate means x coordinate, about the ordinate at x is equal to what? A. The two halves, same two parts are there. Two halves. Half means what? Half parts. Half of they are get divided. Two halves. So obtain. Half part we obtain are coincident. Are what? Lie on each other. Will coincide with each other. Means what? They are just mirror images of each other. That means they are coincide on each other. They are lying on each other. Now the next one is that the frequency curve of such a distribution is what? Bell shaped. Is what? Bell shaped. With symmetrical tail. With symmetrical tail on the two sides. On the two sides. Now the next one says the values of mean, median and mode. Mean, median and mode coincides here. Okay. Next one, median is equispaced. Median is equispaced from upper quartile and lower quartile. Upper quartile and lower quartile. It is equispaced from both of them. Okay, that is what you know. Q1 is lower quartile, Q2 is median, and Q3 is what? Upper quartile. So we can say Q3 minus Q2 is same as Q2 minus what? Q1. This is the meaning of this one. Now the next property of the symmetrical distribution is that the odd order central moments of symmetrical distribution are what? 0. We will see the moments later on. There are two types of moments, raw moments and the central moments. So here one of the property that the odd order central, it is about the central moments. Odd order central moments of symmetric distribution. Symmetric distribution are what? 0. So now let me show you the graph of this symmetrical distribution. These all are what? The properties of symmetrical distribution. If one of them will satisfy, then we'll say this distribution is what? Symmetric. But it is always not possible to us to decide whether which one among these properties will. So if any one of the property will satisfy, but it is not always possible to us to check these ones. So that's why we are seeing the skewness here. Now there are two coefficients with us given by the British biometrician or the statistician Karl Pearson, and other one is what? The Bowley's coefficient of skewness. From these two coefficients of skewness, now the first one, the Karl Pearson coefficient of skewness, is depend on mean, median and mode, while the Bowley's coefficient of skewness is depend on quartiles. It is totally based on quartiles. So from both of them we can easily obtain a result or the conclusion whether the distribution is symmetrical or not. So let me give some examples of symmetry and also the graph of symmetrical curve. The graph of symmetrical curve, as we say, it is a bell shape. That is also known as the, how does the graph? It will be occur as such. It is same on both sides. And here this gives us here the mean equal to what? The median, and that is equal to what? Mode. Here all of them are equivalent. This is known as a symmetrical frequency curve. Symmetrical frequency curve. It is also known as a normal curve, bell-shaped curve or normal curve. Normal curve. Okay. These two names for them. Fine. Now let us see the examples. Some of the examples for the symmetrical distribution. So first one, length of rods produced. Length of rods produced. We say various rods are there. So in the industry, the length of rods produced, they are what? The symmetrical. That distribution is what? Symmetrical. Then second one, weight of contents of packages. Contents of packages filled by a machine. Filled by a machine. Okay. Then the next, length of leaves of a tree. Length of leaves of a tree. Fourth one, height of adults. Height of adults. As such, the various examples we can give. I am giving you just for the information. Now these one are symmetric or nearly so, but mostly these are not that. These are not such example which are not symmetrical. Why? Okay, so this is about the symmetrical distribution. Now let us see the skewness of a frequency distribution. What does that? Skewness of a frequency distribution. Skewness of a frequency distribution. So some distributions which are not symmetrical. Are called what? The skewed. Are called skewed distributions. Or in other words, skewness means lack of symmetry. Skewness means what? Lack of symmetry. So now, for example, we can say income of individuals, number of misprints per page, number of accidents per day. These are what? These are not symmetrical distributions. They may be vary sometime. In different areas they varies. Okay. So now, if some properties, let me see. If the distribution is skewed, or then what happen? Or what are the properties? It will be skewed then first, the observations are not symmetrically placed about the average. Okay. Second, there are more items on one side of the average than on the other. The more items on one side, either on left side or on other side. Fine. Now the third, the frequency curve. The frequency curve of such a distribution stretches one side, stretches to one side and will have a longer tail on that side. Next one, the mean, median and mode are not coincident. Mean, median and mode do not coincide. Next one, the quartiles are not equispaced. The quartiles are not equispaced. That is, Q3 minus Q2 is not equal to what? Q2 minus Q1. This. Fine. Then, now, these are various properties of it. Now, the symmetrical distribution, this is an informative part again, but let me write that so that you can remember it. The symmetrical distribution has zero skewness, but the non-symmetrical or the non-symmetric distribution have may be positive or negative skewness. May have positive or negative skewness. Now, this is depending on in which part of the range of the range, in which part of the range does the distribution has more density of observation. Now, so if the in non-symmetric distribution, if the skewness is positive, then the density of observation is in lower part of range than the higher part of range. Means what? It is near to origin. It is dense near to origin. Fine. While if the density, while the negative skewness was there, then the peak is towards right. So the tail of the distribution, in positive case is towards right, while the tail of the observation is in negative one, it is towards left. Okay, so we will see that thing in next video. What is positive skewness, what is negative skewness. Now here you should remember only, in non-symmetrical distribution the skewness may have two values. It may be greater than 0, it may be less than 0. That's why there are two parts, positive skewness and the negative skewness. Okay, so here we will stop for today for this video. Okay, thank you.